Good morning, all my math friends. So today we're going to be looking at 3 different types of exponent problems. And some of these are a little bit different than what we've used before. So we're going to start with the exponent warm-up to notebook.worksheet. So if you want to pause this for a moment to take a look for the worksheet, that would be great. On the first problem here, I want you to notice that we have 2 different terms separated by a plus sign, and all of this is raised to the power of -2. When we have something like this, what we call a binomial, separated by either a plus or a minus, we have to tackle the problem a little bit differently. We have to follow PEMDAS. Remember, parentheses, exponents, multiplication, division, addition, and subtraction. So first of all, I'm going to be taking a look at this 2 to the -2nd power. I need to work inside the parentheses first, so I'm going to change that to 1 divided by 2 squared. And then this 2 to the -1st power, I'm going to rearrange that, and using my laws of exponents, I'm going to do 1 divided by 2 to the 1st power. All this is raised to the -2nd power. Still working inside the parentheses, my goal is to get this to be one term. So 1 over 2 squared becomes 1 over 4. 1 over 2 to the 1st becomes 1/2. Again, everything raised to the -2nd power. So now I have 2 fractions and I need to get them to be one fraction. So when I combine fractions, I need a common denominator, which is going to be 4. So I'm going to change this 1/2 to 2 over 4. I'm going to add it to the 1 over 4, and that will give me 3 over 4 raised to the -2nd power. So hopefully what we remember from the laws of exponents, when you have a negative exponent, you can take the reciprocal of the base. So the reciprocal of 3 over 4 is 4 over 3. And we change that exponent to a positive value. So really what we have here is 4 squared divided by 3 squared, or 16 over 9. And now this problem is done. The second problem, we can work with this 2 ways. So I'm going to show you 2 ways how to do it. Notice how this one is different from the first problem. The first problem has a plus. The second problem is a product. This makes it totally different. So when we have a product being raised to the power, we can keep the bases and multiply the exponents together. So we can follow our laws of exponents here. So if we keep the base and multiply the exponents, -2 times -1 is a positive 2. If we keep the base, which is 5, and then multiply the exponents, -1 times -1 is a positive 1. So 4 squared is 16, 5 to the 1st is 5, and if we multiply those together, we're going to get 80. Another way to do this is to think about following PEMDAS almost like what we did in the first question. So if we follow PEMDAS here, I'm going to first take this 4 to the -2nd and change that to 1 over 4 squared. And then I'm going to do the same thing with the 5 to the -1st. That becomes 1/5 using our laws of exponents. So I'm working inside the parentheses. This is my P for the PEMDAS. This becomes 1 over 16 and then times 1 over 5. So again, still working to combine this into one term. When I multiply fractions, I multiply straight across. So 16 times 5 gives me 80 on the denominator. And when I think about now raising 1 over 80 to the -1st power, I take the reciprocal of the base and change the exponent to a 1. And so again, our final answer is an 80 here. So 2 ways to do problem number 2. Really only one way to do problem 1, and it's because of that plus sign. So whenever we have a plus or a minus, you have to follow PEMDAS here. Okay, so let's take a look at problem number 3. Problem number 3, Notice how here this one is a little different because we have two terms on the numerator, one term on the denominator. The easiest thing to do here is to break this up into two separate fractions so we can separate the numerator, and we have 3x cubed over 3x to the negative first, and then plus 9x squared over 3x to the negative first. And we can simplify these separately. So notice how over here on the left side the 3's cancel out and we're really left with x cubed over x to the negative first, which really becomes x cubed times x, or x to the fourth power. On the right part we have 9 over 3, which is 3, so we have 3x squared over x to the negative first, which is kind of like saying 3x squared times x to the first power, bringing this up to the top, or 3x cubed. And then we can call that one done. So that's it, everyone.